Question number 61. Which of the following is passive towards concentrated HNO3? If we talk about the nature to be passive, it means there is no oxidation taking place by this concentrated HNO3. We know that concentrated HNO3 is a strong oxidizing agent, but aluminium forms a protective oxide layer over its surface and it becomes passive towards concentrated nitric acid. And on that basis, option 1 is the correct option. While if we talk about other elements, they are not doing so. That's why option 1 is the correct option. Let's take question number 62. Boron nitride has similar structure as of a very simple question. And if we talk about boron nitride, it has graphite-like structure. Graphite has two-dimensional sheet-like structure, and that similar structure is there with boron nitride also. So option 3 is here as the correct option. Now question number 63. Which of the following statements are correct? We have different statements given here, and after the statements options are given here. In this case we need to just find out the correct statements first. In BF3 there is p-pi back bonding between boron and fluorine. So if we talk about this BF3, there is the possibility of back bonding here also, and here also. There is p-pi back bonding. Boron is electron deficient species, and in that case its p orbitals participate in back bonding with fluorine. Means this statement is correct. Further, in Bi3 there is p-pi back bonding between boron and iodine. This is a wrong statement because p orbital of iodine has larger size and this p-pi back bonding is not possible in this case. Further, p-pi d-pi back bonding makes Bi3 least acidic among boron trihalide. If I talk about this Bi3, it is very strong Lewis acid among all the halides of boron. It means this statement is also wrong. Bi3 is strongest Lewis acid among all the boron trihalides. Yes, this is the correct statement because in this case it has maximum nature to gain electron. It means this is the strongest Lewis acid among all the boron trihalide, and that is why option 2 that states A and D are correct statements is correct. So I'll choose it as the correct option. And after this, there's question number 64. The alkali metal ion which has maximum ionic mobility in aqueous solution is. Suppose I talk about the alkali metals. In case of alkali metal, the size of cesium is the largest. But here I'm not talking about only the alkali metal. We're just discussing about alkali metal ions. And if you make aqueous solution of alkali metal where the alkali metal ions are present, there is the possibility of hydration. Definitely hydration would be there. And after hydration, the size of hydrated ion is different from the actual metal atom. It means extent of hydration decides the size of ion, and more the size of hydrated ion, less would be its ionic mobility. So simply if I just want to write here the size of hydrated ion, on which factor it depends? It depends on the size. Smaller the size of ion, more hydration would be there, and after hydration, hydrated ion has different size as compared to the size of normal ion. So this sodium ion is most extensively hydrated among all the given options, so it has the largest size. Further, if I talk about potassium, it has larger size as compared to the next one, that is rubidium ion, hydrated rubidium ion especially, then cesium ion in hydrated form. This is the order of the size of hydrated ion. It means the cesium ion has smallest size in hydrated form, and that's why it has maximum ionic mobility, and on that basis we can choose easily option 4 as the correct option. And after this, it's turn for question number 65. Question number 65. The incorrect statement is, we have different statements given here on the basis of which we need to just find out the incorrect statement. What are these statements? Let's check. the first ionization energy of beryllium is greater than first ionization energy of lithium. The first ionization energy of beryllium is greater than first ionization energy of boron. It means in these two statements we are comparing the first ionization energies of beryllium, lithium and boron. So for them we need to just find the correct order of first ionization energy for these. Now if I talk about the next statement, there's a statement that states, third statement, the second ionization energy of beryllium is greater than second ionization energy of lithium. It means again the comparison of ionization energy, but this time it is second ionization energy for beryllium and lithium. Fourth option, the second ionization energy of beryllium is greater than second ionization energy for magnesium. It means again the comparison of two different elements, and this time magnesium is also there for the comparison of second ionization energy. So in this case, the second ionization energy is compared among the elements which are present here: beryllium, lithium, the same elements as that of previous one, then magnesium, these three elements. Now let's compare the order of ionization energy. If we talk about beryllium, in case of beryllium, the configuration is 2s2, paired electron is there in s orbital, size is small, it needs very high ionization energy to remove first electron, as compared to lithium with the valence electronic configuration 2s1, even as compared to boron that has the valence electronic configuration ns2 np1. It means 2s2 2p1 we are talking about. So this beryllium has more first ionization energy as compared to lithium and boron. Let's check the first and second statement. The first ionization energy of beryllium is greater than the first ionization energy of lithium. Yes, it's correct statement. Further, the first ionization energy of beryllium is greater than first ionization energy of boron. This statement is also correct on the basis of this discussion. Now, we are left with the three elements beryllium, lithium and magnesium, and we need to just compare their second ionization energy. It states second ionization energy of beryllium is greater than second ionization energy of lithium. If we compare these two, beryllium and lithium we are comparing. In case of beryllium, one electron is there that's unpaired, and further if I talk about lithium, after removal of one electron, the second electron removal becomes quite difficult because the configuration becomes 1s2. The charge species with 1s2 configuration, removal of electron is difficult. That's why lithium has more second ionization enthalpy as compared to beryllium. And now the second ionization energy of beryllium is greater than the second ionization energy of magnesium if we compare these two. So definitely second ionization energy of beryllium is greater than the second ionization energy of magnesium, because in case of magnesium the second electron is removed from 3s1 orbital. That's why it becomes easier as compared to beryllium. Now the third statement that states the second ionization energy of beryllium is greater than the second ionization energy of lithium is the wrong statement, while the last one is also correct. So the incorrect statement is given here in option 3, and that's why I'll choose option 3 as the correct option.